All right, so first let's remind ourselves of this property we have for triangles, and it tells us the possible lengths for sides of a triangle. And it states that in a triangle, the sum, which means to add, of two sides of the triangle must be greater than the third side. So any two sides, when you add them together, have to be bigger than that third side. That's the property we're working with in these examples. With that, it asks us, can a triangle have sides length t plus 2, 5t, and t squared plus 2 if t is equal to 3? Well, I can't really compare the sides until I know their actual numerical value without the t's in it. So the first thing I'm going to do is take each of these and put 3 in for t, since it says when t is 3, and evaluate them to find out what numbers I'm working with in this example. So for this first one, 3 plus 2 would give me 5. There's my first side is length 5. This one, 5t, or 5 times 3, would be 15. And in this one, I have 3 squared, if I replace my t, which gives me 3 times 3. 3 squared is 9 plus 2, and 9 plus 2 is 11. So what we're really asking here is, can the triangle have sides length 5, 15, and 11? Well, let's run our test. So again, remember you have to add the sides together. Make sure they're bigger than that third side. So is 5 plus 15 greater than 11? It is. Okay, so that one works. Let's try the next pair. So 15 and 11 have to be greater than 5. Is that true? Well, that gives me 26, which is definitely bigger than 5. Okay, and finally, our last pair we haven't worked with, 11 and 5. So 5 plus 11 has to be bigger than that third side, 15. 11 plus 5 is 16. Is that greater than 15? Absolutely. So all three pairs, when I added the two sides together, they were greater than the third side. So can a triangle have these lengths? Yes. I'm going to show you a shorter way to do this. If you notice, some of these, like this one here, was kind of a no-brainer. 15 is already greater than 11, so if we add anything to it, it's still going to be greater than 11. Same here, 15 and 11 are both greater than 5, so if we add them anything to them, they're going to be even greater than 5. Okay? The only one we have to really worry about is the 5 and the 11. The two shorter ones are not automatically bigger than 15 by themselves. So one way to shorten up the test, rather than testing all three pairs of sides, is just to test and make sure that the two smallest sides, when you add them together, are bigger than the third side. So you would just need to go, okay, my two shortest sides are 5 and 11. 15 is my longest. I just need to make sure those are bigger than that longest side. And again, it does pass the test. Okay, so if you don't want to test all three pairs, at least test the two shortest ones, that when they are added together, they're bigger than that third side. Okay, next, a triangle can have lengths 2x plus 1, x squared, and 3x when x is 3. So again, the first thing we have to do is find out what numbers we're dealing with. Okay, so we have the side 2x plus 1. We're told that x is 3, so we replace the x with a 3 and figure out what number we're working with. 2 times 3 is 6, and 6 plus 1 is 7. So our first side is length 7. Our next one is x squared. We replace the x with a 3. 3 squared is 3 times 3, or 9. And finally down here we have our 3x. 3 times 3 gives me 9 also. So what we're asking is, can 7, 9, and 9 be a triangle? So again, you can do the shorter way, which is just to make sure the two shorter sides, which in this case a 7 and a 9, are bigger than that third side. Or you can do where you test all three pairs. So the 7 plus the 9 has to be bigger than the third side, 9. The 9 plus the 9 has to be bigger than the leftover side, 7. And then the first and last 7 and 9, again, have to be greater than the leftover side, 9. Okay, but you can see in all of these that this does work out. 16 is greater than 9. Here we have 18 greater than 7, yes. And here we have 16 being greater than 9. So all were yes. So we have one big yes. Yes, this can be a triangle. If any of these had been no, our answer would have been no. Again, the shortcut to this is just to take the two shorter sides. We have two that are equal, so the shortest one is 7, and then one of the 9s. Make sure those are bigger than the third largest side. Okay, that's a shorter way. All right, and here's our final example. A triangle can have sides 3x plus 2, x squared, and 2x if x is 8. So again, we can't compare the sides when there's x's in there, so we need to use what they gave us. They said x is 8, so we're going to replace the x with an 8 in each of these so that we know exactly what number we're dealing with in each one. So here 3x plus 2, we replace the x with an 8. 3 times 8 is 24. Plus 2 is 26. Here are x squared. So we have 8 squared. 8 times 8 is 64. And here we have 2 times 8 gives us 16. So can 24, 64, and 16, excuse me, 26, 64, and 16, can those be the lengths of the sides of a triangle? So again, you could use the shortcut way, which is to take the two smaller ones, which would be the 16 and the 26, and make sure that they added together are bigger than that third side of 64. When we add them together, I get 42. Is 42 bigger than 64? No. Okay, so since the two sides, 26 and 16 added together, were not bigger than that third side, this is not a triangle. It is absolutely impossible to make a triangle with lengths 26, 64, and 16.